All right. Finishing polar graphs. We were on worksheets 4 and 5 from an old packet. Remember? And at the top of worksheet 4 were all the really important things you need to know for this. Right here in this little box. Whoa, that's not a box. That's a circle. And to think I teach geometry. How about this? Right there in that little box are all the important things you need. If you have not started this assignment yet for tomorrow's homework check, that's what you need to refer to, okay? We talked about that r theta meant r is the distance out from the origin, which they called a pole, and theta was the measure around, starting off the positive x-axis, which they called the polar axis. If we went counterclockwise, it's positive, clockwise is negative. And we had some blank graph paper thrown in that I may need in a minute. Yes?
Is this the stuff they use on ships when like we'd actually use
Yes,
stuff?
yes. Okay. These, you don't actually have this, unfortunately, so I don't know if you need to write this down, but when you are given a polar coordinate in r theta, this is how you convert it to rectangular, okay? When you are given a rectangular coordinate, this is how you convert it to polar. Does that seem okay? Give you a minute to write that down if you need to. The ideas are on the worksheet, it just doesn't specifically have that slide. Well, that's what you would have to do to solve for theta, would be second tangent of y over x, yes. I just wrote it as the original equation. All right, continuing on, we went through examples and we talked about the fact that there is not a single unique name for a point in the polar system. There are multiple names. What did it mean for D here when we had a negative 230? Anybody remember how we did that? It's this purple one. We turned 30 degrees counterclockwise, but then instead of walking out, we did what? We backed up to was where that negative 2 came from, and that was point D in the black on that slide. Okay. Then we did some converting fun, and then we went the other direction. And then we finally got to the fun of graphing. Yes? Okay. Now, this is where for some reason I'm missing some of the slides. What did you have here? I'm going to pretend this is problem number, what's at the bottom of that page? 4B, okay. On the bottom of 4B, what did you have? 4 sine theta? Did we do those two? Okay. 4 sine theta gave us a what? Gave us a circle up here, whose radius was 4 or 2, all the way across was 4. Okay, so that, could you tell me what problem number that was? Okay, bottom of worksheet.
4B.
Okay, in some classes I got through some of this, some I didn't, so I'm just trying to recap here. Also at the bottom of 4B, was r equals 2 sine 3 theta, and that was our first attempt at making a 3 petal rose whose petals were each 2 units long. And look like that, right? Okay, did we get that far?
Yeah.
And then we got totally distracted because we were playing with our calculators. Okay?
Never get distracted.
All right. We are going to now go over worksheet 5A. All right, this is the actual problem off worksheet 5A. Number 2, put your calculator in polar mode, and I think we did them in degrees, didn't we? So on mode, here we go. We were working in degrees and polar, and then we went to y equals, and this one just says r equals 2. And for a window, we did 0 to 360 because we were in degrees. And you could go with 1 or 5 for the step. Don't go smaller than 1, because it's already at 1 going to have to make 360 calculations, and it will take you a while. Now, I'm going to go -5 to 5 for my x, but then I'm actually going to go to zoom square to let it go ahead and pick, which I think it did 10 to 10 anyway. Anybody get a funny looking, mine looks like a hexagon.
Yep. I got knocked again.
Supposed to be a circle.
I got knocked again.
If I change the step to 1, if I change the step to 1, and I leave this -5 to 5 for my x, and graph it, it looks a little more like a circle, but it's stretched badly. It's because my scale is not good here, okay? I'm gonna try,
Zoom fit?
Don't use the F word.
Zoom fit.
we can try zoom fit, I don't know what it's gonna do.
Zoom fit.
The first one I found Whoa.
Zoom fit didn't change anything. Oh, yes it did. Okay,
Zoom fit for life.
Sniper.
it's supposed to be a circle though, guys, that's not a circle. I did zoom fit and then zoom square. Zoom fit and then zoom square is beautiful circle, okay? Go over here and write this on your graph. What is the radius? Oh, did we talk about putting our calculator in polar? Go second, format, and at the top go to polar. And then when you do trace, it's actually tracing around, like here I'm at 15 degrees around, the radius is 2. If I trace to 45 degrees around, radius 2. So the radius is 2, so it should look like this on your picture. All right, to fill this in and convert, okay? There are some hints here because these are complicated. It says square both sides first. If I square both sides, I get r squared equals 4. But what can I trade r squared for according to our notes?
X squared plus Y squared.
So this will become x squared plus y squared equals 4. Does that look familiar?
Yeah, circle.
So circle with a radius of 2. Is that what we graphed? Okay. Now, which was actually nicer, because I don't know if you remember doing this, but if you want to type this into your graphing calculator, you have to go in Y1 and in Y2. Remember having to do that? Okay. So R equals 2 is a much nicer way to put that into your graphing calculator. Okay, put it in polars. Okay, let's try the next one. On the net, yeah, that's all you're supposed to do is write that down. Did everybody get it down? Get down x squared plus y squared equals 4 and graphed it. Okay. This one is weird, but it says r equals 3 cosecant of theta. How can we type that in our calculator?
3 divided by cosine.
Okay, it would be 3 times 1 over sine, or we could just type 3 divided by sine theta. Okay, type that in your calculator and what do you get? If I left that window, I got nothing.
It's a 3.
Okay,
0, 3.
I'm gonna go back.
I put zoom fit and nothing's going.
Okay,
Give it a second.
I'm gonna
It
go.
said arrow went arrow.
I'm gonna do negative 10 to 10, or negative 5 to 5 actually would be make me happier, but
I think the zoom fit and zoom square works out very well.
did it?
Yeah. I know.
If you wait long enough.
Yeah, arrow window range. Like zoom fit, put it on 7.
Okay. I'm gonna go negative 5 to 5, and then I'm gonna do a zoom square, which is gonna make it bigger, but it is a horizontal line across the screen up at 3. So on your graph paper, you need to go up 1, 2, 3. And it's going straight across. I didn't do a very good job. Okay, it is equation y equals 3. Let's talk about how we get that though. If we have this, r equals 3 over sine theta. If I multiply sine theta over to the other side, it will say r sine theta equals 3. What did we discuss earlier that r sine theta is equivalent to? Y. So, which of those is nicer for graphing a horizontal line? 3 cosecant theta or just y equals 3? Okay, y equals 3 is nicer if you got to put in your graphing calculator, right? Okay, problem number 3. If I told you to graph 2x plus y equals 4 on plain rectangular coordinate graph paper, what would you do?
Negative, yeah. Negative 2x plus 4.
So it would be up at positive 4, and it would cross actually over here, going down 2 and over 1, down 2 and over 1. That's the worst straight line ever, but you get the idea, okay? If we graph this in our calculator, let's see what happens. Oh, we don't know how to graph it in R yet. Okay. We got to figure out how to type that in polar. What we need to do, it says hint, x is equal to r cosine theta, etc. So I'm going to write 2, everybody paying attention, x is r cosine theta, plus y is going to be what? R sine theta equals 4, okay? We're trying to get this to say R equals, because that's what our calculator says, R equals. But only this one has a 2. This one doesn't have a 2. We're going to take out the R. So it'll say 2 cosine theta plus sine theta equals 4. So now, to get the r all by itself, we'd have to do what? Divide. So we're going to have 4 divided by the quantity 2 cosine theta, which will bring up a parenthesis on your calculator, plus sine theta. Okay, we know what that line's supposed to look like. Let's see if we can get the calculator to graph it in polar mode. Four divided by parenthesis 2 cosine theta, close parenthesis, plus sine theta. I don't know if my window's any good. It's not great. It's very curious how it does this. You will notice it starts at the x-axis and goes around, goes up. Did anybody see this, how it did that?
It starts in the expansion and goes on.
Okay, this is a standard window. I'm going to show you what happens. I'm actually going to change this so that it goes slower. Watch what happens. Why is it going up that way and then back?
Calculating up and down 60.
It's calculating around 360 degrees. So it starts at 0 and it goes around. So if I go backwards and turn on my little bouncy ball here, okay, it's going around, and when it hits a certain place here, it comes back around that way, okay? All right, so which is this easier to graph in, polar or rectangular? Would you rather type that in your calculator or that mess? Yeah.
Y equals.
For a linear equation, it's much easier to put it in a rectangular form. Okay, by the way, if we graph this, it goes up at 4 and it crosses over here at 2, so this is what it would look like on your graph paper. If you could draw a straight line, which I can't. But do we have one more of these or not? Okay, this says y equals x. Guess what? Y equals x is what kind of a line? All lines are straight. It's my favorite answer, though.
A curvy line.
It'd be at 0.
Yes, it's this
At the
line,
origin.
right? Slope is up 1 and over 1? Okay. If I write y equals x and I replace this side with r cosine theta, and I replace this, oops, sine is not cosine, my bad. Replace this side with r sine theta, and I replace this side with r
Cosine.
cosine theta, okay?
And divide.
If I divide them both by r, I have sine theta equals cosine theta. Actually, it is. Where does that happen? At the 45-degree angle. If I divide both sides by sine, actually, I'd rather divide by cosine. Boy, I'm not getting this right first try anything today. If I divide both sides by cosine, sine over cosine is tangent. cosine over cosine is 1. So where's the tangent 1? All along that line, right? Now, is there a way to type that in your polar graph? No, because there's not an R here, okay? But it would be where the tangent is equal to 1. Is that all you have? Okay. Yeah, there's extra graphs on the back. And honestly, if you want to just sketch on your homework paper, you don't want to use those graphs on the back, that's fine. You only have to plot like 1 or 2 points anyway. This is the book assignment. Okay. We have a quiz tomorrow. I was supposed to teach eccentricity today, which is not on the quiz. But actually, this is not on the quiz either. Okay? The quiz is on translating conics. I would rather answer questions, and if I have time, look at the getting ready for quiz than introduce something new that you don't have to know. I think that is going to mean we're going to have to push the test off till next week.
Wow.
But I'm sure you're devastated to find out there will not be a second homework check this week then. Okay. Can you find worksheet 19B in the pack I just gave you?
I'm very depressed now.
The pack I just passed out today, 19B. Yeah, I'm not going to go over this. I'm just going to show you where it
Somehow
is.
I lost page 8. Like, I don't lose anything.
Okay.
But I lost that.
I'll figure it out.
Okay.
All right, guys, this is the getting ready for quiz. Does everybody see it there? The answers are at the bottom. I'm not going to go over this right now. This is your responsibility to get ready for tomorrow's quiz, but I wanted to tell you it's there. If you don't have enough questions to entertain us the rest of the period, then we could go and do some of this, okay? But the getting ready for quiz is on 19B. On the quiz itself, you will have to graph some, and there will be graph paper provided. There will also be mostly multiple choice when it comes to pick out the equation. Okay? There'll be some choices there, yes. That makes it easier, I know.
Actual graph paper, or is there graphs on the test?
On the quiz itself, there is a graph paper given that you have to graph these on, okay? All right, we can come back to this if we need to, but right now, I need to answer questions, and I'm gonna just keep recording in case Grace or someone else wants to know which questions we went over. Yes, Jim?
Page 742, did you start?
Okay, 742 is the polar stuff, right? So, no, the homework check is tomorrow, so I can definitely go over that.
But the quiz is too. I'm just kidding,
Yes, yes it is. All right, I thought I had it on here. Here, it's this one. Okay, what number, Jim? Number 7. Okay, let's see if someone can help Jim figure out these. It says convert polar coordinates to rectangular coordinates. Polar means we are given what? R theta. How do we convert them to x, y? Does anybody remember?
Okay, so you have to find pi over the degrees, 60 degrees, 30 degrees.
That is a 60 degree, but that isn't going to help us necessarily change. We could do special right triangles.
Right?
Yep. R cosine theta,
Yeah, whatever that's called.
R sine theta. Okay? Jim, is what you need to do. Now, use your unit circle. What are the coordinates at pi over 3?
1/2 square root of 0.
So this is gonna be 3 times 1/2. And this is gonna be 3 times square root of 3 over 2. So the answer is just 3/2, comma, 3 square roots of 3 over 2.
So is 10 just 2 zeros now?
Yeah,
Yes.
or 2, 2, right?
If you rotate, if you go out, if you rotate around 0 radians and out 2 units, you're right there, which is just 2 zeros in XY as well. Anyone else have a question right now on page 742? All right, what about, yes, go ahead. How I did which one?
So you just went to 60 degrees and you put in cosine and sine.
Yes.
Then will the R always be within the spiral?
Yes, because this polar coordinates are given as an r and a theta.
Okay.
So this is r and this is theta. This is r and this is theta. Okay? Anyone else have a question right now on 742? Okay, what about some of the other stuff? Anybody, the worksheets, 15, 16, 17? Amber? Okay, 726, which is 11.4, is that right? It's just so I know what I'm looking for here. Is it called 11.4? Here, this says 726. I think I found it. Okay, book page. Which one?
Number 9.
Okay, this is number 9 on page 726. A parabola whose vertex is at, and you know me, I have to draw, over 1 and up 0, whose axis, remember that doesn't mean directrix, it actually means axis of symmetry, is x equals 1, that's a vertical line. That tells me right away that this is opening up and down, up or down, I should say. And it goes through the point 213. So over here, it's clear up at 213. All right, an up and down or vertical parabola on your orange sheet says y equals 1 over 4c x minus h plus k. Is that right? Okay. The vertex is at 1, 0. So where can I put that in? All right, so now I have y equals 1 over 4c x minus 1 squared. Anybody help her out? Anyone have any ideas?
Would you put in the other coordinate?
Yep, I'm going to put in x equals 2 and y equals 13. I don't really care what c is. I just need an equation. So basically, I just need to figure out what goes there, right? So if I put in 13 and 2, I think I'm good. Isn't it just 13? 2 minus 1 is 1. 1 squared is 1. 1 times this. So 13 is equal to all that gobbledygook, which means this is my equation. y equals 13 x minus 1 squared. Okay? Now, if we had to find the focus and directrix, then we'd need to figure out what c actually is, but they just want an equation. Is that what the back of the book had, Amber? I hope so.
Can we go over how to get the director again?
Yes. The focus and directrix, you would need to solve this, okay? So you would get, is it 42? Thank you. 52? Yeah, 52. I thought 52, but then I thought I was probably making that up. So they would be really disgusting for this problem, but the focus would be inside of here, 1/52. So it would be at over 1 and up 1/52. Okay? And the directrix would be 1/52 this way, and remember, it's perpendicular to that axis of symmetry, so it's going the other direction. So that would be y equals negative 1/52. Don't have to have that for that question. Ben just asked me to review that. Yes? In the book?
Yeah.
Okay. I'm going to back up and talk about number 8. This is a hyperbola question. So totally different place on your orange reference sheet. It says we have a center at -3, -5, and a vertex at -3, 0. The center for a hyperbola is actually just the center of the box, right? Okay. And this tells me, if this is an actual vertex, that it's opening sideways. Okay. Oh, thank you. Thank you, thank you, thank you. Mine is wrong. Thank you for not waiting until I totally screwed up the whole problem. All right. Clearly, the vertex of -3, 0 is here. So it does mean it's opening this way, right? My bad. Okay. So what's the general form look like when we have a vertical hyperbola? Anybody find it? Okay. The center tells me H and K, right? So I'm halfway there. Be careful. K is -5 and H is -3. So I have y plus 5 squared minus x plus 3 squared equals 1. Anybody know the one other piece of information we already know? The direction up and down, the distance that this went from -3, -5 to -3, 0 was 5 units. That's in the y direction, so this is 5 squared, or a is 5. So that's going to be a 25 in a minute when we simplify everything down. Then, any ideas where to go from there?
This is where I sat.
Okay. Yes, we have this equation, the asymptote equals this. Well, I don't know why they wrote it like that. Sorry. The equation we have on our sheet looks like this with the slope as, isn't it a over b for this one?
Yeah.
Because it should be change in y over change in x. So if we got this in a form that at least had a slope, we'd be in better shape. That reduces to what? 5/2, but I really don't care. All I care is the slope is 5/6. So this is 5/6. We're really lucky. Sometimes they'll give you something that reduces or you have to multiply. But if A is 5, B is just 6. That was about as hard as they get, in my opinion. I usually mess these up because when the hyperbola is opening up and down, the H and K aren't in order on the problem, and that messes me up every time. Does someone else have a question I can help with on anything that's due tomorrow? Is that worksheet 17 or a bookwork question? Okay, worksheet 17. Is this the top of 17, Ben? Does it say hyperbolas or?
Yeah.
Okay. All right, what can I help with?
Start with number 6.
Am I still on side A? Is this the right number 6? Okay. What is this graph?
Circle.
Whose radius is?
5.
Okay. Line of symmetry. Anybody have an answer? All the rest of these equations, Ben? Go through the origin, and any line that goes through the origin, no matter whether its slope is shallow or steep, whether it's positive or negative, they will all be lines of symmetry. This equation, though, starts up to and goes this way, so it would like be a chord of a circle. It would not be a line of symmetry. Okay? Be careful, guys, on the homework check. Some of you like to fill these bubbles in, and then somebody's going to write down that it's B or C or something. It's supposed to be H, okay? Be careful because it goes F, G, H, I, so I can't really count B or C right. You have to tell me it's H. What else?
Figure out my
No one else has a question right now? Jim, did you want me to go over something on the worksheet 19? Whoops. Okay, is there a particular question you want me to talk about? Okay, number 2 is an ellipse. This is looking ugly, isn't it? Okay. Can we find the center? Isn't the center halfway between the vertices?
Yeah, well,
Yeah, because 8 and 8 added together divided by 2 is 8. If we add 3 plus the square root of 95 and 3 minus the square root of 95, we get 6 divided by 2 is 3. All right? But if the vertices are added and subtracted to the y, doesn't that mean it's opening, or it's this way? Oh, I don't know what that is.
That's a yeah.
It's a potato, okay. But if the center was at 8, 3, and you went up here to 8, 3 plus the square root of 95, and down here to 3 minus the square root of 95, that's crazy. Okay. So that means it's got a bigger number under y. I'm just going to go ahead and write it in this order because I know it's an ellipse with a plus. This entire distance is 2 square roots of 95, right? Square root of 95 in each direction, so this is a 95. Now, okay, a squared minus b squared equals c squared. And c squared is this. Isn't that 50? Yep. Oh, if this is not 95 squared, then 95 is already squared. 50. Oh, we gotta add though, don't we, guys? So we get, that's not working for me. Is that the right answer? Anybody have the answer? What? 145 or 45? Wait a minute. The distance out to the foci is the square root of 45. No. Square root of 50. Yes, the foci right here are square root of 50. No, I don't. Yeah. So a squared should be 145. Is that not what they have?
I think they did the wrong. I think they did like the a squared.
Doesn't it say in its ellipse in the directions?
Yeah.
Yeah, I'm thinking theirs is wrong. It should be 145 right there. It's a multiple choice question. Guess I should double check that they're right.